Hello everyone, welcome to Komal Vision's YouTube channel. Today's video is about reminder theorem in 9th standard mathematics textbook, where this reminder theorem is in the polynomials chapter. This is very important for your annual examination as well. Based on this theorem, you will going to get your future mathematics content more and more. So that is why let us learn what is meant by reminder theorem. So usually you people were supposed to solve problems with the division like this. I'll take one example. I should divide 5 with 3 here. So obviously I should go for 3 ones are 3, because if I go for 3 twos are 6, what happens here? I'll get more than 5, which I can't subtract. That is why I'm going with 3 ones are 3. 5 minus 3 will be 2, where this 3 is called divisor and 5 is called dividend. I'll write it as DIVT, okay, divided, and 1 is called quotient, 2 is called remainder, which is represented with R, correct? So this is the remainder. So there is a formula in order to verify whether we have done correctly this division or not. How to verify? You might have seen in your lower classes, the dividend is equals to I will write here, the dividend is equals to divisor into quotient plus remainder. That is, what was our divisor before? Our divisor was 3 into our quotient was 1 plus what was our remainder? 2 in before formula, before problem. So, and our dividend was 5. This was what the formula in order to verify our division process. If you see here, our dividend was 5, which is equals to divisor was 3 into quotient was 1 plus 2 is the remainder. When I solve these again, whatever you have on the RHS side, I should get again LHS part, which is nothing but 5. Let us see whether we'll get or not. 3 into 1 is 3 plus again 2 I have written here same as it is, which is equals to 5. I'll be written as it is here, and 3 plus 2 is 5 again here. Okay, so if you see here, LHS part is equals to RHS part, then we have done division correctly. Is it clear? So this is how the division process will be done for numerical values. What about for the polynomial expressions, how to do the division? So let us see how the traditional method is happening for polynomials by taking one example. So there is a way to divide the given expression with the algebraic term. How we used to divide? This is an algebraic term what I have written here, which is nothing but a polynomial. So, and the degree of this expression is 3, because the highest power is 3 in this expression, and I want to just divide for each term with x, because I want to divide whole expression by x, right? So in the first step itself I am just dividing each term with x here. So again 3x square by x, let me write it 2 here properly, plus x by x. I have divided each term in this expression with x separately. So if you see here, in the numerator and denominator I have x terms, so I can cancel. So I'll be left with 2x square, because 1x gone in this expression, plus 3x square was there. When I divide that with x, one expression gone, so it will be 3x plus xx gone, 1 will be left there. Some student used to leave it as it is and they used to write 0 there. You shouldn't do like that. Okay, so if you see, this is what one method of doing division for polynomials. We can do like this. This is what the answer. Okay, if they give throughout the expression variables means you can easily divide. If they give numerical values in the expression, what will happen? Let us see. So have a look at this example. I just want to divide the throughout expression by x here. So I'll do that. I'll just separately divide each term with x. So 3 by x I'll get at the end. Later on, if you guys see, here I have x, here I have x in the both numerator and denominator, I can cancel them. I'll be left with 5x plus. Here I have x and x, I'll be left with 1 plus. Here I have 3 by x, I can't divide numerical value with x here. So that is why I left with 3 by x, which is not a justification answer for this polynomial expression, which is not a suitable answer for this polynomial expression. So we are ending up with the remainder as fraction. We know that whenever you get the remainder, it should be not a fraction, correct? So we are getting here 3 by x, which is an which you cannot cancel it out. So that is why what we'll do, we'll go for the remainder theorem for this kind of expressions. Okay, in this chapter we are going to learn this kind of polynomials division through remainder theorem, which is very easy. I'm gonna solve one problem in this video as example problem given in your textbook. Okay, so this is what one of the example I have selected from your textbook, that is NCERT textbook. So here p of x is nothing but a polynomial. Again, a g of x is nothing but a polynomial. We used to take p of x or g of x to represent the variable, to represent the polynomials in one variable, that is x. Is it clear? Okay, now I should divide p of x with g of x here. So for that, what I do, I'll just take 1 plus x as a divisor, okay, and x square x plus 3x square minus 1 as a dividend. Okay, let me write it down. So I'll write here, the problem was, the divisor was 1 plus x and the dividend was, here we had x plus 3x square minus 1 was the dividend, but what I do is I'll just rearrange the terms here, because always I want highest power variable as a first term in the polynomial expression. That is why what I done here, I just reversed the term here. I just shifted the terms here, so that the expression will become here 3x square plus x minus 1. Is it okay? So now I just want to find out the remainder and quotient for this. Here it is plus, don't get confused. Okay, 1 plus x it is. Now, and also here also I can make some difference. 1 plus x can be written as x plus 1. Why? Because here in the first term I have variable, so I want in the divisor also first term as variable itself. Okay, then only our division process will be easier for you. Okay, now what I just want to do in this remainder theorem division is, I just want to cancel, as we have done in numerical division. All we have to do is we just have to cancel the first term present in these expressions. Okay, so what should be multiplied to x in order to cancel 3x square here? 3 should be multiplied and 1x should be multiplied, so it would be 3x square. Is it okay? Now I have plus 1 as well here, so I should not forget it. So I should just divide, I should just multiply 3x into 1 here. So 1 into 3x is 3x again. Okay, and now you have to change the sign present in a second row. Okay, if you have plus, you should make it as minus. If you have minus, you should make it as plus. Then only we can cancel. Otherwise, how can we cancel? Because both the terms 3x square, 3x square has positive signs in front of it, we can't cancel. In order to make it as negative, we should change the sign. Okay, first step is we should make the first terms as similar as that given in the expression, and later we have to change the sign. So plus will become minus. Now what I do here, I can easily cancel because plus 3x square minus x 3x square get cancels. Now here if you guys see, minus 3x and plus x is there. When you just cancel minus 3x uh, and plus x with it, you will get obviously minus 2x, correct? So minus 2x minus 1 will be left with. Again, if you see guys, we have first term in the polynomial expression as minus 2x. In order to get minus 2x as a first term, what I should multiply to x here? Again, the same procedure you should repeat again until and unless you get the remainder as 0 or one single number. Okay, you should all do is you should be cancelling out these variable terms. That's it, simple. Okay, so minus 2x I should get here. For that what I do, I want negative sign, and also I want 2. X is already here, minus 2 if I multiply means it will be sufficient. So minus 2 into x is minus 2x, and my plus 1 into minus 2 is minus 2. Got it? So here I should change the sign. Minus will become plus, minus will become plus here again. So I have changed the sign as a second step. Now minus 2x plus 2x get cancels. I'll be left with 1 plus 2 minus 1 plus 2, which is equals to 1, which is equals to what here? 1. So our remainder is 1 here. Did you just guys understood how we should solve polynomial expressions? By remainder theorem. All I have done is I should make the highest power in the expression as a first term, and I alternated the divisor terms because I want variable terms highest power in the expression as a variable term first expression. Okay, and next I done is I just thought of making cancel the first term here. So that is why I just multiplied the suitable terms in order to get the same term of the expressions having first term. So I just changed the sign and cancelled it out. Later what I have done here is I wrote the remainder left. Again I done the same procedure. I wrote the remainder as 1 here, which means until and unless you get your numerical value as a reminder, you should keep on continue the procedure. Okay, so this is what the reminder process. Okay, you can do verification as well. As I have told you, dividend is equals to divisor into quotient plus reminder. This can be applicable for this as well. You can just check it out. You will definitely get this expression. Okay, so thank you. That's it for today's video. I'll continue. I'll come back with more and more problems regarding remainder theorem. Okay, thank you.